Combination. You have considered permutation. Combination simply means the arrangement of objects for which order is not considered. For which order, the other time we said for which order is considered. So this is sign of combination. We say n combination R is n factorial over n minus r factorial, r factorial. And also it can be written as n permutation R over r factorial. Now let's evaluate this. N combination R, follow what is there. N is our n, this is our r. It should now be 8 minus 3 factorial, 3 factorial. If it is permutation, it will have stopped at this place. This one will not be included. But if it is combination, this 3 will be included. Then we now say 8 over 8 minus 3 is 5. And simplifying this will give me 56. Also, 9 combination 5 is 9 factorial over 9 minus 5 factorial, 5 factorial. 9 minus 5 is 4. 4 factorial, 5 factorial. And that will give me 126 by the time I simplified it. Now, we give it here that combination can be written as permutation over r factorial, over this factorial. That means I can treat combination in terms of the way I treated permutation the other time. That means I can say that a combination 3. I'll first treat it like permutation. That is, I will say that 8 will be reduced in 3 places. That is 8, 7, and 6. This is 8, 7, and 6. You remember that is how we did permutation. So if it is now combination, I can treat it like that, but I would not say that over these 3 factorial. And from that place, this will be cancelled out because 3 factorial is 6, 3 factorial is 6, and that will give me 56. 8 times 7. You see that it is easier than this. So that means the second one, 9 combination 5. I will write 9, I will reduce it in 5 places, and that will give me 9 times 8 times 7 times 6 times 5. That is 1, 2, 3, 4, 5 in 5 places. That is the meaning of this. Then since it's if it is permutation, I will have stopped like this. But since it's combination, I will say over 5 factorial. And it will be easy for us to simplify here. So our answer is 126. So with this idea, I can say that n combination 3. I'll first treat it like permutation. I will say n into n minus 1, n minus 2. That is, I reduce n into 3 places. 1, 2, 3. But since it's combination, I will say that over 3 factorial. So that means if I have n combination 2, it can be equal to n into n minus 1. That is n in, we reduce n in 2 places. 1, 2. Then divided by 2, I will say 2 factorial. So this will help us to treat more some tedious question on this combination. Let's consider this example. Find the values of n. A, the first one, n combination 2 is equal to 15. I'll first treat as permutation. It will be n into n minus 1, then over 2 factorial. That will be equal to 15. So the whole of this is our n combination 2. Then we cross multiply. If we cross multiply, it will be n into n minus 1 equal to 2 factorial is 2. Then if you cross multiply, it will be 2 times 15. That is 30. As usual, we look for two numbers that will give us 30. That is 6 and 5. Finally, I can say that I will pick the first one, which is n. I'll pick the first one, which is 6. So the final answer to this is 6. Let's consider another example. So if you consider this, n combination 3 is equal to 20. Our n combination 3, I will reduce n into 3 places. That will be n into n minus 1, n minus 2. Then we say over 3 factorial because it's combination equal to 20. Then we cross multiply. 3 factorial is 6. If you cross multiply, it will be 20 times 6. That is 120. So we are going to have n into n minus 1, n minus 2 equal to 120. Then we look for three numbers that will give us 120 because we have three here. 1, 2, 3. Definitely we have to look for three numbers that will give us 120. And the numbers will be 6, 5, and 4. 6 times 5 times 4 will give me 120. So we are going to have this. That is 6, 5, 4. So we just pick the first one. N is the first one. 6 is the first. So N is equal to 6. If you have done it right, you are going to get it. If you have not done it right, if you just pick N is equal to the first one, you'll be missing the question. Because N is bigger than all this. Definitely 6 is bigger than all this. Then pick the first one. 6 is equal to N. So our N is 6. If it is the second one you pick, you say N minus 1 is equal to 5. You still get N is equal to 6. So let's pick another example. Let's consider this example here. N permutation 4 equal to N combination 2 times 1, 1, 2. The first thing is we need to express N permutation 4 in this format. N permutation 4 will reduce N in 4 places. That is N into N minus 1, N minus 2, N minus 3. So we have 1, 2, 3, 4. This is N permutation 4. We are not saying over again because it's permutation. But if it is combination, N combination 2 will be N into N minus 1 over 2 factorial times 1, 1, 2. From this place, 2 factorial is 2. So 2 will cancel 1, 1, 2 to give me 56. So this is the 56 here. So what we now have is N into N minus 1, N minus 2, N minus 3 is equal to, this cancels. We have 56, N into N minus 1. And from this place, N into N minus 1 is common. They are both common to both sides. So we can cancel them out. N cancel N. N minus 1 cancel N minus 1. All we have left is N minus 2, N minus 3 equal to 56. But we look for two numbers that can give me 56. That is 8 and 7. 8 comes from before 7. That would not pick the first one, which is N minus 2 equal to 8. So if you make N the a formula, N will be equal to 8 plus 2, which is 10. So N is equal to 10 is our answer. So let's look for, let's consider some word problem on this. Move to application of combination. If they say combination, combination simply means, in a short form, it simply means to pick, to select, to form, to choose. That's what I mean by combination. Now, if you look at this question, a committee of 5 is to be selected from 8 members. So the word selected here means combination. In how many ways can this be done? So if you are that means we are selecting 5 from 8 members. So our answer is simply 8 combination 5. If the word is talking about picking, selecting, formulation, to choose, there is combination. So our answer is just 8 combination 5. This is 8 combination 5. And mind you, there's something you should know about combination. If I say that 8 combination 5 is same thing as 8 combination 3, because 5 and 3 will give me 8. So 8 combination 5, that is its own advantage over permutation. 8 combination 3 will same thing as 8 combination 5. And that will give me 8 times 7 times 6. I'll stop here because it's to 3 places. Then over 3 factorial. 3 factorial is 6. So our answer is, it cancels this. So our answer is 56. Now, that is our answer. There's something to buttress more on this. If I have 9 combination 5, 9 combination 5 will still be same thing as 9 combination 4, because 5 and 4 will give me 9. So in that case, I can say that 6 combination 5 is same thing as 6 combination what? 6 combination 1. I can say that 8 combination 2 is same thing as 8 combination 6, because 2 and 6 will give me 8. So that is one advantage. So that means if I'm asked to find 17 combination 15, which should be too long, I can reduce it to 17 combination 2. So these two will be easier for me. I will just say it is 17 times 16 over 2. Then I am done. Unlike this one that is very long. So let's consider another example. So any question that is talking about selection or picking, there is talking about combination. So what we now want you to gain here is that anytime we see combination or permutation, anytime we see select any of this word, then you should know that it's combination. Our answer is combination. So if I say that I want to pick 10 people from 100 people, definitely the answer will be 100 combination 10. So let's consider conditional arrangement under combination. Let's consider another example. In how many ways can 5 prefects be chosen from 11 students such that A, there is no restriction? If there is no restriction, that means there is no condition attached to it. We are only selecting 5 from 11. So the answer is just 11 combination 5. So we should be able to deal with this. So 11 combination 5, what that will give us? So it will give me 462. Now the second one says 3 particular students must be included. That is, in the committee, 3 particular students must be included. Anytime you hear the word must be included, the number that must be included, you remove it from these two, from this 11 and this 5. So our answer will now be 3 particular students must be included will be 11 minus 3 combination 5 minus 3, and that will be 8 combination 2, and 8 combination 2 will be 8 times 7 divided by 2, that is 28. The third one, 3 particular students must be included. If they now say that they must be included, you only need to remove the number that is given to you from this top one alone, because since they must not be included, so definitely you still need 5, and you remove 3 from the total because 11 is the total. You have to remove 3 from it. So our answer here will just be 11 minus 3 combination 5. Here means 3 must not be included. If they say that 3 must be included, you have to remove the 3 from both ends. So our answer will be 8 combination 5. And 8 combination 5 can still be 8 combination 3. So which will give me 56 ways. So that is that. Let's consider another example on that. An SRC consists of 6 members. In how many ways can this SRC be formed from 10 students? If there is no restriction, let's treat that. There is no restriction means there is no condition. So our answer will be 10 combination 6. That is, we are selecting 6 from 10. So in that case, our answer will just be 10 combination 6, which is same thing as 10 combination 4. And it will give us 210 ways. In 210 ways. Now, the question now says 4 particular students must be part. That is, must be part of the committee. 4 particular students must not be part. This one, 3 particular students must be part. Now let's first talk about 4 particular students must not be part. If 4 particular students must not be part, I will only remove the 4 from this place. If they say that they must be part, then I will remove it from the 2, just like what we did here. So this B says 4 particular students must not be part. So our answer will be 10 minus 4 combination 6, and that will become 10 minus 4 combination 6, and that is 6 combination 6, and that is 1. That means in just one way. And the last one says 3 particular students must be part. If they say must be part, I will remove 3 from here and 3 from here. That is, they must be part. So our answer will now be 10 minus 3 combination 6 minus 3, and that will become 10 minus, this is it here, which is 7 combination 3, and that gives me 35. Look at this example 3. A committee of 4 men and 6 women is to be formed from a group of 7 men and 9 women. You observe that for our previous examples, we are not discriminating here. Here we are discriminating men aside, women aside. Whenever you are giving a question that is discriminating like this, you have to write them separately. Men aside, women aside. If there's another gender, we'll continue. Now, you put the group here. The group must come first. In the group, there are 7 men there and there are 9 women. In the committee, for the men, I have 4, and for the women, I have 6. This first one says if there's no restriction. If there's no restriction means there's no condition. So that means we'll be selecting 4 men from 7 women. Our answer is 7 combination 4 times we'll be selecting 6 from 9 women. So that will be, you say times, when when they are discriminating like that, we say times this combination this one means there's no restriction, and this one will give me 7 combination 1 will give me 35, 9 combination 6 will give me 84, and that gives me 2940. Now the second one says 2 particular women must not be there, and I told you if they say must not be there means that you remove from this place, from this women combination here, must not be there, you only remove the 2 from 9 here from the top. The men are still intact, but the women now will remove 2 from the 9 because the question says must not be included. If they say must not be included, I will only remove the number given to me from the top, and that will be 7 combination 4 times this will become 8. This will become 7 combination 6, and this is 35. This one is 7, and the multiplication gives me 245. The last one says 2 men must be included and a woman must be included. So if they say 2 men must be included, that means I have to remove 2 from both ends here. For the men, this is for the men, and for the women, I have to remove just 1 from the 2 ends, and that is 7 minus 2 combination 4 times 9 minus 1 combination 6 minus 1. That gives me this. So my final answer there is 80. Look at another question here. A committee of 6 boys, 7 men and 8 women is to be formed from 7 boys, 8 men and 9 women. In how many ways can this be done if there is no restriction? 4 men and 3 particular women must be there. A particular couple must be there. A particular couple must not be there. So this is the group, the class, 7 boys, 8 men and 9 women must come first. The committee will follow, or any group that want to be formed. That is 6 boys, 7 and 8 has been given. 6 boys, 7 men and 8 women. Now the first question says there's no restriction. If there's no restriction, our answer will just be 7 combination 6 times 8 combination 7 times 9 combination 8. So we have it here, and the solutions are there for the B and for the C, for the D. So you can read it up. So that is that about permutation and combination. I would like to video this textbook so you read more on the textbook. So starting from factorial here, this is factorial. You pause it so that you can read it very well. So this is factorial. This is permutation. This is permutation. Questions on permutations are there, which I have treated before. Nkankan. So that is combination. You have taught that before.